Welcome to the Math Show Skill Drills with Mr. DeClerico. If you're like me, you like to be appreciated, or at least remembered. So we can both be grateful that we are not the method of completing the square, because no one really appreciates or remembers how to do it half the time, which is why I'm making this video. Consider these two equations, both of which yield the same solutions. Let's look at the equation on the left. I can apply a square root to both sides if I want to solve for x, realizing that x minus 4 can be equal to plus or minus the square root of 24, which would boil down to 2 root 6. From there, it's pretty easy. I would just add 4 to both sides, and I get my two solutions. Now, my equation on the right is a little more frustrating. I wish I had this binomial squared right here, but I have an x squared and a negative 8x, and a constant 8 on the other side. No convenient binomial squared. However, I could try to subtract an 8 on both sides and factor, but you will very quickly realize that this does not factor in the integers. So there may be a way to take my equation on the right and make the equation on the left. But how? There is an answer, but just warning you, this is a nerd alert. The explanation I'm going to give you is quite nerdy, so you might want to skip ahead till we get to the practical stuff. I want to introduce you to one of the greatest mathematicians of all time, Muhammad ibn Musa al-Khwarizmi, who says, "I got your back. Let's try my technique." Let's consider this generalized quadratic expression, x squared plus some constant, let's call it b, times x. And let's make it the area of a rectangle. The rectangle would look something like this, an x by x square and a b by x rectangle. Now I can create an almost square by taking that b by x rectangle and splitting it in half and arranging it so. Wouldn't it be awesome if I could, gasp, complete the square? Well, what would the area of that little red square be? If we consider the dimensions of our split rectangle pieces to have that little length of 1/2 b, we see that the area of that little red box that completes the square is half of b, pause for emphasis, squared. The area of this completed square would be x plus 1/2 b times x plus 1/2 b, which is an ultra convenient squared binomial. Cool, right? Now, I know what you're thinking, and Al-Khwarizmi might too. If you're not as much of a nerd as we are, then here's what you need to know. To complete the square for some generic quadratic expression, like x squared plus some constant x, we would add 1/2 b, pause for emphasis, squared. That is to say, we half then square the coefficient of x and add it onto our expression. If you ever remember your math teacher saying, half then square some number, this is probably what they were talking about. Now let's go to that problem we tried before and couldn't factor. We notice that negative 8 is the coefficient of x. Al-Khwarizmi would say, let's complete the square. We're going to take that negative 8, half it, negative 4, and then square it and get 16. So we add a 16 to the left-hand side, which means we need to add 16 to the right-hand side. Factoring the left-hand side, we get x minus 4 quantity squared. Adding 8 and 16, we get 24. Then we apply a square root to both sides, and you know what happens next because we've already done this problem. X is equal to 4 plus or minus 2 square roots of 6. That is the answer. And now we can get it thanks to Al-Khwarizmi's completing the square method. Now, you may have a question at this point. Why can't we just use the quadratic formula? Well, Al-Khwarizmi might say, silly student, the quadratic formula is completing the square. If you took a generalized quadratic equation and solved for x using completing the square, you would get the quadratic formula. Plus, there are some applications that require us to complete the square, specifically those involving graphs of circles, ellipses, and hyperbolas that you might see in algebra, geometry, or trigonometry and pre-calculus courses. Now let's look at another example. The first thing you should note about this example is that the leading term is not just a variable squared. It's 4x squared. I need to do something to get rid of that 4 if I want to complete the square. My leading term must be just a variable squared. So I'm going to look at my first two terms, and I'm going to factor out that 4 I don't want. Lucky for us, that's easy to do. After that factorization, I'm going to complete the square within the parentheses. I see I have a 4 as my coefficient of x. So I half then square, which means to complete the square, I would have a 4. Now notice I need to add a 4 times 4 on the right-hand side. What gives? Well, I added a 4 within the parentheses on the left-hand side, which means I actually added a 4 times 4. So I need to add a 4 times 4 to the right-hand side as well. After the dust settles, I can factor that trinomial in the parentheses to be x plus 2 quantity squared. Then, adding a 13 to both sides, I would get 29. Then I divide by 4, and then I square root both sides, and then I would subtract 2 on both sides. Basic algebra from there. And that's how I get my answer. Now here are a couple problems for you to try. Feel free to pause the video and try to solve for x all on your own by completing the square. Resist the temptation to use the quadratic formula. Alright, I'll assume we're ready to continue. The correct answer is -3 plus or minus 2 root 5. Let's try another. 2x squared minus 4x equals 9 has that interesting wrinkle we just talked about. My leading coefficient needs to be 1. Consider how you would rectify that problem. Pause the video and try this one on your own. Alright, I'll assume we're ready to continue. The correct answer is x equals 1 plus or minus root 22 over 2. Note that the root 22 over 2 was obtained by rationalizing a denominator. Thanks for watching this video. And if you're feeling what this frog is feeling, check out my website in the description. And as always, be sure to click subscribe, hit the like button, and all that good stuff.